Cert-manager adds certificates and certificate issuers as a custom resource types in the Kubernetes cluster. It simplifies the process of obtaining, renewing, and using those certificates. Cert-manager can issue certificates from a variety of supported sources, including Letsencrypt, HashiCorp Vault, Winafi, as well as private PKI. The typical workflow will look like this. You create a certificate issuer, for example, Letsencrypt. When you create an ingress for your service, you will specify in the annotation that you want to use that Letsencrypt issuer to secure your ingress. When you apply, the cert-manager will detect that annotation and issue a certificate from Letsencrypt and store it in the Kubernetes secret that ingress can use it. Cert-manager provides custom resource issuer that namespace specific and must be used to obtain certificates in the same namespace where it was created, and cluster issuer, which can be used in any namespace. Similar to RBAC role versus cluster role. Also, in this video we will monitor certificates and the cert-manager with Prometheus and Grafana. I'll show you how to define Grafana data source and a dashboard in the code rather than do it manually from the UI. You will be able to see all the certificates and expiration dates in that dashboard. You can use Alert Manager to set up alerts if those certificates are close to expiration and weren't renewed. In this video we will go over 5 examples. In the first one we simply create a self-signed certificate. The primary use case for self-signed certificates is to use as certificate authority to issue other certificates. In other words, to bootstrap your PKI, public key infrastructure. In the second example we will use that self-signed CA to create another type of the cert-manager issuer, which is CA. For the third example, we would need to deploy Nginx Ingress controller and a Grafana. Sometimes we want to have private host names, and the only way to get certificates for them is to use your own CA and issue certificates. You may think that it's secure enough to keep them with plain HTTP on a private subnet. But in this example, I'll show you what can happen in the case of man-in-the-middle attack. We will use Wireshark to capture raw TCP packets between the Grafana and us. We will create a capture filter to only watch for post requests to Grafana and update the credentials, username and a password. After that, we will secure Grafana Ingress with a certificate that will be issued from the same CA that we created previously. Finally, in the fourth example, we will create a Letsencrypt issuer and obtain the certificate using the staging environment first. For this example, we will use the HTTP 01 challenge. The most important lesson here is that I'll show you how to debug if you face all sorts of issues. Our fifth and final example will use the Letsencrypt issuer that will use the DNS 01 challenge. Here I'll show you how to transfer the subdomain to Route 53, in my case the monitoring subdomain. To follow along, you would need a Kubernetes cluster. You can easily create one using EKSCTL tool and myconfig. By the way, all the commands that I run in the video and the source code are available in my GitHub repository. First, let's check if we can connect to our cluster. It's a standard check that returns the Kubernetes API service in the default namespace. I'm trying to make all my videos self-contained that you would have all the components needed for the following examples. Most of the cloud-native services, such as cert-manager, Nginx Ingress, and other, expose metrics in the Prometheus format. Where I can, I try to use those metrics in my videos and create Grafana dashboards for them. This video is no exception, and we will need to deploy the Prometheus to our cluster. If you want to learn more about Prometheus, you should watch another video how to install Prometheus on Kubernetes cluster. Let's quickly deploy Prometheus. We have CRUDs folder with custom resource definitions. Then we have Prometheus operator that will monitor those CRUDs and create corresponding objects in Kubernetes. And finally, we have Prometheus folder. We have RBAC policies and the main Prometheus object to create Prometheus instance. Here are few important configurations. Prometheus will watch service monitor objects with the label Prometheus equal to less than 83. By default, Prometheus will only detect those service monitor objects in its own namespace, in this case monitoring. We can instruct Prometheus to select service monitor objects in all namespaces with the label monitoring equal to Prometheus. We need it since the cert-manager Helm chart will create a service monitor object in the cert-manager namespace. Now let's go to the terminal and apply those folders one by one. First, let's create custom resource definitions for Prometheus operator. Then let's deploy Prometheus operator with its RBAC policies. And finally, the Prometheus itself. Prometheus operator will convert Prometheus custom resource into stateful set and a config map. Now let's make sure that Prometheus is ready before we can continue. The next step is to deploy a cert-manager. Whenever you deploy your services in Kubernetes with YAML or Helm, it's a good starting point to take open source Helm chart and adapt it to your environment. Then you can generate YAML files and apply them, or just override default Helm variables and install it using Helm. Let's see what default variables are in the cert-manager Helm chart. You can find it in the Jetstack cert-manager GitHub repo. We're going to override a few of them. I assume you already have Helm CLI installed. Let's add that Helm chart repository. Let's search to see what versions are available right now. This is one of those tutorials where you want to install the same versions first. We have a lot of moving parts: Nginx Ingress, Kubernetes versions, and cert-manager. Let's use the 1.5.3 version, which is the latest one at this moment. Create cert-manager values.yaml file to customize the Helm chart deployment. First, we need to enable CRUDs. Helm chart will create the following custom resource definitions: issuer, cluster issuer, certificate, certificate request, order, and a challenge. Then let's enable Prometheus metrics and create a service monitor object. This label has to match to the one on the Prometheus object. This Helm chart will take the Prometheus instance key and convert it to simply Prometheus. We're going to add a few more later when we get to example 5. Now we can optionally generate YAML files by using the Helm template command. Provide release name, chart name, namespace where you want to deploy it, version of the chart, the path to the values that you want to override, and the output directory. Let's see what we got. All the files will be placed in the Helm generated YAML folder. For example, the cluster resource namespace flag will specify the namespace where the Kubernetes secrets will be created when you use cluster issuer instead of issuer. When you deploy the Helm chart to the namespace that doesn't exist yet, you can use the create namespace flag. For this example, we want to create a namespace ahead of time. We need a cert-manager namespace to have monitoring equal to the Prometheus label. In order to Prometheus, select the service monitor object. Go ahead and create a namespace first. Now let's use the Helm install instead of the template and provide similar flags. This will deploy CRUDs and the cert-manager pods. When you use Helm tree to install the chart, it is a namespace scoped. Let's make sure that all the pods are ready. We have 3 different services. The main one is the cert-manager, then the CA injector, which helps to configure the CA certificates for mutating webhooks, validating webhooks, and conversation webhooks. And a webhook, one of the functionality is to ensure that when cert-manager resources are created or updated, they conform to the rules of the API. Simply that you provide only valid arguments. Now let's verify that the Prometheus config was updated and we can monitor the cert-manager. Let's port forward Prometheus operated service and go to the target section. Alright, we have the cert-manager target. Later on, we will deploy Grafana with a dashboard. Let's create our first example with a self-signed certificate to bootstrap our CA. The first step is to define cluster issuer. It's going to be the simplest one. You don't need to specify the namespace, since it's a cluster scoped and only one parameter is self-signed. It's not the certificate, it's just a resource that we will use to generate one. Now create a CA certificate. Kind is a certificate, then you need to specify the namespace where the certificate and a key pair will be stored. Let's make it as CA, which means we can use it to issue and sign other child certificates. The typical duration for the certificate authority is 5 years. Then the common name, it doesn't really matter what you will put there. It doesn't have to match with existing domains. Then the Kubernetes secret name. The cert-manager will generate a private key and a certificate and place them into the secret in the cert-manager namespace. Then you can choose what algorithm you want. The final step is to specify what cluster issuer you want to use. This should match the one we just created. Let's go ahead and apply the example 1 folder. To get the certificate, run kubectl get certificate in the cert-manager namespace. This object does not contain the certificate and a private key itself. Instead, it has a reference to the Kubernetes secret. Now let's get that secret. The certificate and a private key are stored in the DevOps by example IO key pair secret. Let's get it from there. You can use the output YAML flag to get base64 encoded values. This secret contains the private key stored in the TLS key secret key, then the certificate in the TLS cert. Since it's a self-signed certificate, TLS cert is equal to CA cert. Let's get the value and decode it using base64 tool. -d to decode and -o to provide the file name where we want to store it. Now to make it human readable, run the OpenSSL command and provide the path to the certificate. You can see that it's a CA certificate. It will be expired in 5 years. The next example will use this certificate to issue a new one. You don't have to use CA that we generated. If you have an existing certificate, you just need to import it to the Kubernetes using the secret. Create a new example2 folder and the cluster issuer. To indicate that we want to create a certificate authority type issuer, you just need to specify the CA key and provide the path to the Kubernetes secret. Since it's a cluster issuer, that secret must be located in the same namespace where we deployed cert-manager. This can be modified with a cluster resource namespace flag. This secret DevOps by example IO key pair was generated in the first example. Here I want to create a certificate in another namespace. Let's create a new one and call it staging. Then a certificate itself for the block DevOps by example.io. Give it a name and a namespace. This will place a certificate and a secret in the staging namespace. Then set CA to false. Choose a duration. Letsencrypt issues certificates for 90 days, so let's use that magic number here. Then you can define when the cert has to be renewed, the common name on the certificate, and a list of DNS names that you want this certificate for. This field will be translated to subject alternative name on the certificate, Kubernetes secret to store key pair, algorithm for the certificate, finally cluster issuer, which is based on our CA. Let's apply all of them. List certificates in the staging namespace. If the status is ready, means the key pair was generated and stored in the Kubernetes secret. The secret name is block DevOps by example IO key pair. Let's print that certificate and decode it with OpenSSL as we did it for CA. The difference here, now TLS cert and CA cert is different. Let's store it in the file as well. Here you can see two hostnames, block and www block. They came from the DNS names key on the certificate object. Also, it's valid not for 5 years, but for 90 days. Next, we need to deploy the Nginx Ingress controller. In this video, we will quickly override few variables and deploy using Helm. If you want to learn more about Nginx Ingress, you should watch Nginx Ingress controller for Kubernetes tutorial. To start, add the Ingress Nginx repository and run Helm update. For this video, we will use the 4.0.1 version. Let's create Nginx Ingress values and override few default variables. First one we need to give to Ingress class name. Then let's disable the webhook for now, just to avoid additional complexity. It does not affect the Ingress, it only verifies if your Ingress config is valid before updating the Nginx. Also, in AWS, when you use the service of type load balancer, AWS will provision a classic LB. Let's upgrade it to the NLB network load balancer using this annotation. Now, this is important part that needs to be configured to pass the HTTP 01 challenge. By default, the Nginx Ingress controller doesn't watch any more ingresses with the Ingress class annotation. It will only select ingresses with the new Ingress class name key. Since cert-manager still creates ingresses with depreciated annotation to pass the HTTP 01 challenge, we need to enable watch ingress without class and give it a name. We need to pass the ingress class flag as an extra argument to the controller. That's it for now, let's go and deploy it. Provide Helm release name, chart name, namespace, version, values, and enable create namespace, since it doesn't exist and we're not going to monitor Nginx Ingress in this video as I did in the previous one. Let's verify that Ingress controller is ready before proceeding. As I mentioned, the primary mechanism of specifying Ingress class is a new type called Ingress class. Now let's deploy Grafana. It will be used both to illustrate how to create ingresses with cert-manager as well as to monitor certificates and expiration dates. First, let's create a Kubernetes secret with username and password encoded in base64 format. The user is admin and the password is DevOps123. Then create a config map with a datasource.yaml key that will be used as a file name when we mount to the pod. You can create a data source from the UI or you can predefine it in the YAML. Since Prometheus is deployed in the same monitoring namespace, we can just use the Kubernetes service name, Prometheus operated, and the port. Also, we're going to put our cert-manager Grafana dashboard to the config map and mount it as a file as well. We need to provide the path for Grafana to discover our dashboard. This is our cert-manager dashboard defined as a JSON object. Finally, in the deployment, you can see that we create volumes from all of those config maps, Kubernetes dashboards, data sources, and dashboards. Then we mount them to the pod. We need a service to create ingress later. Now let's go to the terminal and apply the Grafana folder. We're going to use the Grafana service in the ingress definition with the port 3000. Time for the third example. Ingress objects must be created in the same namespace where you have your service. Now let's use the Ingress class for Nginx Ingress controller, define the domain Grafana, DevOps by example.io, and the service. First, we create Ingress without TLS section and cert-manager. Later, we will come back to it and secure it with HTTPS. Alright, we have Ingress for Grafana. Now we need to create a CNAME record that will point to AWS public load balancer hostname. My domain is registered with Google Domains, but it doesn't matter. You just need to create DNS record and point to that LB. Let's check if we can access Grafana. For now, use HTTP. It works. Let's enter admin for the username and DevOps123 for the password. We have a data source that points to the Prometheus out of the box. Also, we have a dashboard. Currently, we have only 2 certificates and the soonest expiration is almost 90 days. Now we need to sign out, since we want to test if we can get credentials in plain text when someone logs in. In this example, I want to use Wireshark and simulate man-in-the-middle attack. Wireshark is a widely used network protocol analyzer, used for troubleshooting, analysis, software and communications protocol development. Let me install it with Homebrew. I'm not going to use UI, just a command line interface. And instead of display filter, I'm going to use a capture filter. They have different syntaxes. To start, we need to specify the network interface that you want to attach with Wireshark. You can list network interfaces with ifconfig or ipadder command on Linux. Let's use EN1 as our primary interface with a private IP address. First, you need to provide the network interface EN1-X for output of hex and ASCII dump packet bytes. Then let's create a capture filter for Wireshark. We can use Boolean expressions and, or, etc. First, we want to monitor traffic that comes to the Grafana developed by example host. Then we know that it is on standard port 80, since ingresses only serve HTTP on port 80 and HTTPS on port 443. Then the most interesting, we want to capture only post requests. Let's open ASCII table. Let's convert post to the ASCII hexadecimal values. Capital P translates to 50 or to 4F, S to 53, T to 54. Then when the TCP packet arrives, we check if it contains post. Finally, let's redirect output to the file post. To test, go back to the Grafana and enter your credentials. We can see that we captured one TCP packet that satisfies our filter. Let's open it. Alright, we got the username and the password in the plain text here. Now let's secure it with TLS and test it if we can read TCP packets and get the password again. We want to use the cluster issuer that we created in the previous example number 2. Then we can optionally define the duration and the renew field. Also, we need to add a TLS section. Hosts will be used as subject alternative names and name of the secret where you want to store the certificate and a private key. Let's see if the certificate was successfully issued by the cert-manager CA issuer. It is in a ready state, so we can continue. If you list ingresses, you can see additional port 443 that was added to the Grafana ingress. Now you need to use HTTPS. It works, but since it was issued by the self-signed certificate, it's not trusted. Let's add CA to the keychain on a Mac. Let's select the CA. We created this file in the first example when we generated a self-signed cert. Make it trusted. Now, if you refresh the page, the error should disappear. This certificate is valid. Let's use Wireshark to capture some packets on port 443. We can use host and post request since those packets are encrypted and we don't have access to the content of the TCP packet. Let's see. Now all the packets that we get with Wireshark are encrypted and we can't get a username and password as well as any other useful information. Example number 4. Finally, we're going to start issuing certificates from Letsencrypt. In this example, we will use Letsencrypt staging environment, and in the fifth example, we will use Letsencrypt production environment. Now instead of cluster issuer, let's use issuer. It's not a big difference, it's just you can use that issuer only in the namespace where you created it. Here we're going to use the ACME key. ACME stands for Automatic Certificate Management Environment Protocol. Always use staging environment first when testing Letsencrypt automation, then provide the real email. In case if Letsencrypt fails to renew the certificate, you will get an email with a warning, then the secret name. For solvers, you can use either HTTP 01 challenge or DNS 01. On line 16, we specify what ingress class will be used to resolve that challenge. cert-manager will create additional temporary ingress using that class to prove to Letsencrypt that we control our domain and a server. Then almost identical, but the issuer is for production Letsencrypt environment. If you use this one, you will get a valid certificate. The difference here is only the server URL, well, and a different secret name and an issuer name. Let's apply folder example 4. Before using those issuers, check if they're in ready state. If you describe the issuer, you should see the message that the ACME account was registered. Now let's create ingress for Prometheus. I mentioned in the previous video, in general, it's a bad idea to expose internal services to the internet, but here we have only one single public ingress, so let's do it. In the annotation, use issuer and not cluster issuer that points to the Letsencrypt, then the pretty standard fields for the ingress. Point to the Prometheus Kubernetes service. Now I think the most important part of the video. I'll show you how to debug the issuer if the cert-manager fails to obtain the certificate. The flow when you're using ACME with cert-manager is the following. First it will create a certificate, then it will check if there is a valid one already. If not, then it will create certificate request. Then the certificate request will create an order and finally a challenge. Let's see if the certificate is ready now. Nope, it's false. Let's describe the certificate to get more information about the problem. You can see certificate request was created. It was approved, but it's not ready. Let's describe it as well. Order was created and the certificate object waits till it's done. Let's move to the orders then. We have only one order for the Prometheus certificate. Let's describe it. Alright, order created the challenge. Let's list and describe the challenge. You see it's in pending state. Finally, we get a meaningful message. Prometheus develops by example.io, no such host. Well, it's expected since we never created CNAME for our Prometheus ingress. Also, when the cert-manager creates ingress for the HTTP 01 challenge, it will also spin up the pod. You need to make sure that that pod is in ready state. After you pass HTTP challenge, certbot will delete that pod. You can see that it's running. Also, we have ACME Ingress. Now here, if you're not going to specify the Nginx Ingress watch ingress without class, that ingress will be ignored and you will not get the load balancer hostname. Let me print out the ingress. You're not going to find the Ingress class field here, only the annotation Ingress class equal to external Nginx. By default, Nginx Ingress will not watch those annotations anymore. Before I create CNAME, let me split the screen. In the first one, I will run get certificates, and in the second one, get challenges. That's actually a reason why I use DNS01 challenges in my production environments. It allows you to create ingress and obtain the valid certificate without creating a CNAME and redirecting traffic to the service that is not ready yet and does not have the valid certificate. Now let's create a CNAME for Prometheus Ingress. It's going to be the same load balancer hostname as for Grafana. Challenge was completed and it disappeared, and the state for the certificate changed to ready. If you check the Prometheus in the browser now, you get a certificate, but it's going to be from the staging environment. You can see that the certificate is not trusted. To get a real one, just use Letsencrypt HTTP 01 prod issuer. It's time for the last example. First, we're going to delegate a subdomain to Route 53 and create DNS01 Letsencrypt issuer. You can delegate the whole domain to Route 53, but just for this example, I decided to delegate only the monitoring subdomain. That means that all subdomains such as Grafana monitoring develops by example.io will be resolved using Route 53 and not Google domains. First, we need to create a public hosted zone in Route 53. Let's call it monitoring develops by example.io and keep the public hosted zone. In the future videos, I'll show you how to create private hosted zones and use OpenVPN to push DNS name servers to your development host that you can resolve private host names. Delegate subdomain is very easy. You just need to create NS record for your subdomain and point to Route 53 name servers. Let's do it now. Now let's test the subdomain, create a record and try to resolve it locally with a dig. IP address can be anything, it's just to test DNS. Alright, we successfully delegated monitoring subdomain to Route 53. Since we will use IAM roles for Kubernetes service accounts, we need to create OpenID Connect first. If you maintain your own Kubernetes, for example with kops, you need to create a similar IAM role and attach to the Kubernetes workers. We need to get an OpenID Connect URL from the EKS cluster. Then use it to create identity provider. Now we need to create IAM policy and grant access to create DNS records in Route 53. The way the DNS 01 challenge works, you need to prove to Letsencrypt that you control domain by creating a specific TXT record with a token that Letsencrypt gives you. When Letsencrypt verifies that you have a TXT record, they will issue a certificate. You need to do it every time whenever you want to renew your certificate, approximately every 60 days. You can see why without automation it's not a viable option to renew certs by yourself. The first statement is to be able to get the current state of the request, to find out if DNS record changes have propagated to all Route 53 DNS servers. The second one, to update DNS records, such as TXT for ACME challenge. We need to replace the ID with the hosted zone ID. Let's give it a name, cert-manager, Route 53 access, and click Create Policy. Now we need to create IAM role and associate it with the Kubernetes service account. You need to select the OpenID Connect provider under Web Identity. Let's call it cert-manager ACME. Later we will use this IRN in the Kubernetes service account. To allow only our cert-manager Kubernetes account to assume this role, we need to update trust relationships. Let's find out the name of the service account attached to the cert-manager deployment. It's called cert-083 cert-manager. Here update the audience to sub and STS Amazon AWS.com to the service account. Cert-manager is a namespace for that service account, and the last argument is the name of the service account itself. We completed the IAM configuration on the AWS side. Now we need to update a couple of Kubernetes objects. To specify the IAM role to use by the service account, you need to add an annotation. By default, it will use the one that is attached to the Kubernetes workers. This Amazon resource name you can get from the AWS console. That has to be your account ID. We need to update deployment as well to include additional flag to the cert-manager. You need to add issuer ambient credentials to be able to use that IAM role. If you are using cluster issuer, you need to add or replace this one with cluster issuer ambient credentials. When you make this change, Kubernetes will recreate a pod. By the way, the cert-manager Helm chart allows you to specify those configuration options before you install it. In the Helm values, you can add service account annotation with the IRN of the IAM role and extra arguments as well. Let's create the final example with the DNS resolver. It's going to be similar to the first one for the staging environment. The difference here, instead of HTTP, use DNS, then specify the region and the Route 53 hosted zone ID. The second one is for production environment to get real certificates. We will use this one for the last certificate. The difference is in the server URL. Let's create the last Grafana ingress and use that DNS issuer. Under issuer, specify Letsencrypt DNS01 prod. The rest of it is pretty standard: hosts, secret and a service. Let's split and watch those certificates and challenges. And apply example 5 folder with the issuers and Grafana ingress. Let's check if the cert-manager was able to create a TXT record. Yep, it's here, Magic ACME challenge record. Challenge state transition to valid, and in a second window certificate will be ready. If you have any issues, the best way to find the error is in cert-manager logs. Now we need to create a CNAME record for Grafana in Route 53, since we delegated the monitoring subdomain there. It's a valid certificate issued for 90 days by Letsencrypt. If you log in to Grafana, you will find more certificates there. Thank you for watching, and I'll see you in the next video.